bit about position vectors. It's really, really easy. Here's the recap. It's just a square root. We take the components of our vector, we square them, we add them, we take a square root. Yep, distance formula, it's just because one of your points is 0, 0, it's easy. If we want to add vectors together, now here's something that's really interesting. We knew that we could take vectors and put them end to end and add them, right? And go from starting spot to ultimate ending spot. Well, we can do that mathematically too. And it's really, really easy. If you want to add vectors together or subtract vectors from one another, just subtract the numbers, man. That's all we got to do. So if we're starting at A and if we're starting at the initial point of A and ending at the terminal point of B, and we want to add those vectors together, if we just add these component by component, that takes care of vector addition for us. It also takes care of vector subtraction for us. It's really straightforward. Add the components. Just make sure you don't screw up the components themselves, okay? So if we want to do vector A plus vector B, we can do A1 plus B1. We can do A2 plus B2. And then it gives us a new vector, and that's how we add vectors together mathematically. Very straightforward. Also, hey, we knew that we could grow a vector or shrink a vector by multiplying it by a scalar. Do you remember talking about that? Those numbers, just those numbers, like multiplying by 3. This right here, this scalar C, which I'm going to use to represent a scalar, if I wanted to multiply a scalar times a vector, all that happens here is that we take each component and multiply it by that scalar. And now we get to practice a couple of these things. So what I want to do right now is basically this is enough for you to go and do it. You could probably do it. Magnitudes are really easy. It's easy to add. It's easy to subtract. It's easy to multiply. I want to give you at least one example to see that you guys can do it. Then we'll talk about unit vectors, and I'm going to talk a whole bunch about that and a special way to find unit vectors. So here we go. Example time. So let's say I started off with vector A and vector B. I want to find a couple things. Can we do it? Let's see. What's the number 2? What's that doing there? What would you call that if you had to say anything that's
scalar?
Perfect. So scalar number 2 just times the vector A, whatever that is. What do you think it's going to be? So when we're multiplying a scalar times a vector, literally all it's saying is, hey, take every component here, multiply every component by 2. That's what we're talking about here. It says take the scalar, multiply every component by that scalar. So if I want to take the vector A and multiply it by the scalar 2, we're going to get -2, we're going to get 4, and that's what that vector is. -2 times, then that's extended the length twice. That's what's happening. Show hands if you're okay with that one. Okay. How about A plus B? Let's see if we can do that one. We'll write this one out for this one at least. If I wanted to add vector A plus vector B and not have to draw the picture because I don't want to do that anymore. I want to be able to do it mathematically. What's the first number I'm writing? Good. We add our x components first, so our -1 or 3 first. Then we add our what's the other ones? Just like the slope formula, it's really easy to screw up numbers in this. Just, man, mind your numbers. Just go slow enough so you're not making mistakes on it. It's really easy to make mistakes in this class because you deal with a lot of numbers. But we're kind of back to that, right? It's easy to screw those things up. Just go slow enough that you don't mess that up. Maybe we'll double check your work every once in a while. What are we going to get? You can say it louder, man, because the air conditioner's on and everything.
230.
I'm going to do this one with you. I want you to do this one on your own here in just a second. I'll give you some time for that. Let's try a minus b. Notice with a minus b, graphically, we would have to switch around that a plus negative b to make that vector go the other way. But when we're doing this just algebraically, it's even easier. Literally just subtract them, because we can do that with our numbers now. So if I wanted a minus b, this looks like -1 minus 3 and 2 minus 1. Make sure we're using our vector notation because these are changing to position vectors. I'm looking at -4, 1. Did you guys get the same thing? I got it. That's the idea. It's pretty straightforward. Do you think if I give you some problems like this, you could do them? Yeah. How about this one? Let's talk about it. Then I'm going to give you some time to do on your own. Try this. What would you do first on this problem? Can you find a magnitude right now with this? I don't know. What do you think? Okay, so the whole idea here says, all right, well, I'm going to need to figure out, condense that out, just like order operations. I'm going to figure out what this is. I'm going to need to know what 2a actually, well, I already have that. I'm going to need what plus b is. So I'd be taking basically this vector plus this vector, figuring out what that is, and then finding the magnitude of that. Does that make sense? Try it. I'll give you about 30 seconds, see if you can find the magnitude.
Absolute.
Oh, yeah. My bad. Yeah, so it happens when you drink too much absolute, right? I mean, wait. This is water, I swear. It's a joke, come on. Yeah, thanks for, you know what, when that happens, would you please catch me on that? Because how I grew up doing this was with just the one. I like the two better. I think it's less likely to have ambiguity. So when I make that mistake, catch me on it. You know, at this level, I don't care how fast you do this stuff. You want 13 steps or 1 step, I don't care. I really just want the right answer. Does that make sense? I don't care all the work you're showing me. I really don't. I need you to know how to get this vector and that vector. That's the money. That's what I want. So the 2a plus, if you can do the scalar number 2 times the vector a and add the b and do that all at once, great. I probably wouldn't try to do the magnitude all at once. That's not something I would want to do. What I would do is figure this guy out. So this vector, what is that vector when I take 2 times vector a plus b? What would you get? Yeah, it's really this plus that, 1, 5. That's a position vector. And then I'm going to take the magnitude of that position vector. Tell me simply how I take the magnitude of a position vector. How do I do it? Square it? Add it? Perfect. So the magnitude is going to be 1 squared plus 5 squared, square root. Looks like square root 26 to me. Did you guys get square root 26? Leave it. That's it. That's what I'm asking you to do. Now, the last two things we're going to talk about are unit vectors. We're talking a little bit about it right now. I'll show you how to do it. It's very, very easy. We'll talk about a different way to describe vectors, very useful. I'm going to come back to unit vectors and show you something really kind of cool. With me? You don't even know yet. You will. You'll know.
Unit vector. What's the word unit mean? Like in math, we talk about unit. What's? I mean, sometimes it means like miles or gallons or stuff. But we're talking like a unit vector. That idea unit vector says, and some of you guys raise your hands, and you're right. It has a certain length. A certain length. If I say unit, means 1. So a unit vector is simply a vector with a length of 1, or a magnitude of 1. Say what?
It's a unit circle.
Ooh, we'll talk about that. That's the interesting part.
A vector with a length or a magnitude
Of 1. You can change any vector into a unit vector. It's not hard to do. How would we do it? Let's say we had this vector and it was it had a magnitude of 3. How would I make the 3 into a 1? Divide by 3. What if I had a length of -5? What would I divide by? Yeah. Let's divide a vector by its magnitude, and it will always give you a unit vector. Does that make sense? If we take something that's 5 units long, divide by 5, it's going to be something 1 unit long. That's how unit vectors work. So unit vectors, very easy to find. Take a vector, divide by its magnitude, unit vector.
to find the unit vector from any position vector.
Divide by magnitude. I'm going to say it simply, just divide by magnitude. Of course, it's math, right? So I got to give you some notation. Let's talk about unit vectors. For us, we're going to use U to mean the unit vector. However, because it has a length of 1, because it's a kind of a special idea, there's a little bit more notation I'm going to put up here. When we're talking about unit vectors, we don't have this thing anymore, because that stands for a position vector. That's what that is. So when we're talking specifically about a unit vector, we say, you're so special, you get like a party hat, man. We're going to give it a party hat. We literally are. It's a little hat up there. Give it this little arrow thing. Kind of like if you were ever in statistics, you had P hat, Q hat. That's what we have. It's that same symbol. This is what defines for us a unit vector. How we do it, it's super easy. You take whatever vector you're given, so let's say we have vector v, we divide by the magnitude of vector v. That's going to give us a unit vector. Now here's something that's also interesting. How about this? Hey, we still know how to do algebra. Could you solve this for that vector? Okay, the answer is yes. How do you solve this for that vector? What would you do? This says something. Every vector can be defined by a magnitude times a unit vector. Did you guys see it? A magnitude's a scalar. That's really interesting. This is kind of cool. It's really cool. It says that if I want any vector in the freaking world, all I need is a direction times a scalar. All I need is a direction times, and I can grow a unit vector into whatever vector I want. Does that make sense to you? And that's what this next thing is going to say. So if I solve this for vector v, we can define a vector as magnitude times direction, or magnitudes times a unit vector. So when we do it, we say, hey, let's just multiply. So we got vector v equals magnitude times direction. how I would like for you to think of a unit vector is direction. So when we have this unit vector, it's got a length of 1. That's kind of like our standard unit, right? It's saying that's our basic thing here. That's what I want you to think of is direction. So when we think unit vector, you think what? No. Okay. When I think unit vector, yeah, it's got a length of 1, but I want you to think direction. So word association here, people. Unit vector? Direction. Let's try this again. Unit vector? Direction. Oh, you got it. Geniuses, all the direction. Yeah, so unit vector means direction. It's giving us the direction of our vector. Are you understand what I'm talking about? It's kind of like saying this. It's saying, hey, I was traveling north at 60 miles an hour. Awesome. What direction did you travel? North. That's what a unit vector is. It's just giving us that direction, our heading, if you will. Are you with me on what I'm talking about? The 60, we lose that magnitude. It's just now has a direction. That's it. We can't have a magnitude, well, we can have a magnitude of 0, but if we had a magnitude of 0, it wouldn't point us anywhere. Does that make sense? You gotta have at least something to say this is where you're headed. That's your direction. So we're gonna try just one of them. I just want to do one example here about how to find a unit vector. We'll talk about these things called standard basis vectors. Let's see where we're at there. So I want to find a unit vector. So here's what I'm saying, okay? If I say I want to find a unit vector, I want to find a vector in the same direction as this, but having a length of, how much? Come on, unit vector has a length of? 1. Perfect. I'm basically just looking for the direction of this vector. That's all I want. So let's try that. Name me the 2 things you need to figure out a unit vector. What do you need? You need a vector. We got a vector. And you need what else? Go ahead and find the magnitude right now. Can a magnitude ever be negative? No. That's why it looks like absolute value. It's giving us just a distance.
Yeah, this is kind of negative.
I got 2. Did you get 2?
Yes.
That's awesome. Square it, add it, square root 2. Are we done? Is 2 the unit vector? No, 2's the magnitude of this specific vector. Let's go ahead right now, let's find the unit vector. So our unit vector says, all right, what we do now is we take the original vector and we literally just divide it. Notice what we're doing. We're dividing by 2. Wait, what is 2? Would you define it as a scalar or a vector? Can we divide by scalars?
Yes.
Can you multiply by scalars?
Yes.
So if we're dividing by 2, it's really multiplying by 1/2. We're just dividing this by 2. We're cutting the vector in half. It's the same exact thing. So what we have for our unit vector is negative square root of 3 over 2 and 1 over 2. I want to show of hands if you feel okay with that so far. You know, a lot of times, a lot of textbooks could also do this for you. Instead of just having this 2 in the vector itself, a lot of times they'll write it like this. They'll take that unit vector portion, the magnitude of it, and they'll write it out front, especially if it's a really nasty fraction. They'll write it out front, and they'll leave the original vector alone. And you can also write a unit vector that way. So, and you can kind of see it, right? It looks a little bit better even sometimes. It says, hey, here's your original vector, and I'm taking half of it. And that would give me the unit vector. Are you guys okay with this one? You sure? Any questions at all so far?
Still with
First.
Still would put the U in Right, equals.
Yeah, it's the same exact thing. It's the same unit vector, man. It's the same thing. It's just I'm choosing not to distribute the 1/2 or divide by 2 on both, or I'm choosing to. They're
Just take
name me the two, but having a unit. So I want to find a unit vector. So here's what I'm saying, okay? If I say I want to find a unit vector, I want to find a vector in the same direction as this, but having a length of, how much? Come on, unit vector has a length of,
One.
perfect. I'm basically just looking for the direction of this vector. That's all I want. So let's try that. Name me the two things you need to figure out a unit vector. What do you need? You need a vector. We got a vector, and you need what else? Go ahead and find the magnitude right now. Can a magnitude ever be negative?
No.
That's why it looks like absolute value. It's giving us just a distance.
Yeah, this is getting bigger.
I got 2. Did you get 2?
Yes.
That's awesome. Square it, add it, square root 2. Are we done? Is 2 the unit vector?
No.
No, 2's the magnitude of this. Did you get 2? Just a distance.
Yeah, this is getting bigger.
I got 2. Did you get 2?
Yes.
That's awesome. Square it. Add it, square root 2. Are we done? Is 2 the unit vector?
No.
No, 2's the magnitude of this specific vector. Let's go ahead right now, let's find the unit vector.
So our unit vector says, all right, what we do now is we take the original vector and we literally just divide it.
Notice what we're doing. We're dividing by 2. Wait, what is 2? Would you define it as a scalar or a vector? Can we divide by scalars?
Yes.
Can you multiply by scalars?
Yes.
So if we're dividing by 2, it's really multiplying by 1/2. We're just dividing this by 2, we're cutting the vector in half. It's the same exact thing.
So what we have for our unit vector is negative square root of 3 over 2 and 1 over 2.
How much? Show of hands if you feel okay with that so far. You know, a lot of times, a lot of textbooks could also do this for you. Instead of just having this 2 in the vector itself, a lot of times they'll write it like this. They'll take that unit vector portion, the magnitude of it, and they'll write it out front, especially if it's a really nasty fraction. They'll write it out front, and they'll leave the original vector alone. And you can also write a unit vector that way. So, and you can kind of see it, right? It looks a little bit better even sometimes. It's It says, hey, here's your original vector, and I'm taking half of it. And that would give me the unit vector. Are you guys okay with this one? You sure? Any questions at all so far? First.
Still would put the U in front equals.
Yeah, it's the same exact thing. It's the same unit vector, man. It's the same thing. It's just I'm choosing not to distribute the 1/2 or divide by 2 on both, or I'm choosing 2. Neither one's much more better, all right? Same stuff. So this is a different way to write it, that's all. Other question?
Can we do it back with the exam? Or do you want to-
Both the same. I don't care. Yeah, I don't care. As long as you know how to find a unit vector, I'm happy, man. If you can find a unit vector, that's good to go. What if I asked you this question? What if I wanted a unit vector in the opposite direction of V? Question. Is this going to be a whole lot more work than this one? What do you think? Let's talk about it. Unit vectors do this, right? Unit vectors take a vector and divide by the magnitude of whatever vector I'm working with. So, firstly, is the magnitude going to change for this vector? No matter what I do, is the magnitude going to change? Is the vector going to change? The vector itself. Well, if I want the opposite direction, okay, come on, put it all together. How do I find the opposite direction of a vector? Put a negative in front. Do you remember that V and negative V were the same kind of they're parallel, but they're opposite directions? Remember that? So if I ever wanted to find a unit vector in the opposite direction of V, here's a unit vector in the opposite direction of V. Do I have to recreate all of this work? The magnitude's not going to change, guys. The vector's not going to change. All this would be, our vector here, would be one of two choices. You can either have positive 3/2 -1, or even easier, just make it negative 1/2 and keep the same exact vector. Those would be the unit vectors in opposite direction. Hey, you know what? It's the same unit vector. It's just the opposite direction. Literally, that's the idea. Show of hands if I've made this make sense to you. Feel okay? All right. last thing, I think we'll start here next time. I want to talk about these things called standard basis vectors.
The distance value is going to be exactly the same thing if we do a minus b dot magnitude. So we can compile this. It's going to work. And yeah, still have the same distance. Any other questions before lunch? Any thoughts? How to make a game like Angry Birds? I can't answer that. That's a very long question and a whole production pipeline. Start doing things. That's how we make games. Generally speaking, no one's going to get mad at you for doing a minus b dot magnitude instead of vector 2 dot distance. I don't think so. I mean, the first one might be slightly more esoteric because you sort of need to know the underlying math for that to be readable. But I think most people should know about that. It's a very important concept. Like vector 2 dot distance, the nice thing about using that one is that you're being very explicit that you literally want the distance between 2 points. If you use the a minus b dot magnitude, it's a little unclear. Like, you get the length of the difference between these two, but like, is that interpreted as a distance? Maybe these aren't points, maybe this is something else. So, sometimes it's useful to like use the one that literally says distance, because it's very clear that you kind of want a distance, right? And conversely, if you want to do the same math as this, but it's not a distance value, then using vector 2 dot distance is likely going to be more confusing than useful, right? So it kind of depends on the context. I personally really like doing, like being explicit and clear with my code. Hugo, you're spoiling it. I haven't gotten to that yet. But yeah, actually, we can just talk about that. But that's the last thing before lunch. Okay, so we talked about we have this line right here, right? The one that's pointing in the direction of this transform, right? So what this one is, that is the normalized version of that point. Like this is the only thing we've done there. So the way to calculate a normalized point, so instead of just doing dot normalized, we can do the point and then we divide it by the length of that point, right? So point dot magnitude. So this is how you normalize a vector. So by dividing it by the length, the length becomes 1, right? Yeah. So that's how you normalize a vector. I previously talked about the fact that there is a degenerate case where you're dividing by 0. And if you look at this equation, you can probably tell it's normalize a vector. Yeah. So that's how you normalize a vector. I previously talked about the fact that there is a degenerate case where you're dividing by 0. And if you look at this equation, you can probably tell what the degenerate case is, right? Because points.magnitude can be 0. So what that means is that point is at 0. So if you have a point that's at 0, and your goal is that you want to get the direction that this point has from the origin. But if the magnitude is 0, then you're dividing by 0. So now, again, math is telling you that something is messed up and you need to think about what you actually want to do here. So what this means is that you're trying to figure out a direction of a vector that doesn't have a direction. It's 0. It doesn't point anywhere, right? So usually in these cases, you need to figure out, okay, what do I do to handle this special case? If it's at 0, do we want to fall back to just using 0? Do we want to check if the length is 0 and then not draw it or not execute some piece of code? Usually it's really like every time you see a division operator, it's really useful to think about if the denominator can ever be 0. If it can, then that means that you have an interesting case to solve. Yeah. All right, I think that's it for lunch. Yeah, we're going to talk about the square magnitude stuff that you're talking about in the, like after the break. And yes, doing square magnitude is faster. Yes. I think there are some intricacies of like, the property call itself has some weird overhead, but if you manually do the square magnitude, it's like way faster than actually doing magnitude. So I've heard. But that's not for mathematical reasons. That's for silly overhead reasons. Actually, we should do a lunch break. Okay, I'm just, there's no audio in the lunch break room, so yeah, I'm just gonna place an image here. See you soon. See you after lunch. Look at that little boy. Sleeping in the goblet. He's a peaceful little cat now. Where were we? Oh, we just covered how to actually normalize vectors, how to do that, right? Not just in terms of what it is, how to do it using Unity's helper, but how to actually do it yourself, right? Okay. What's the state of things? So we have our code and we were just showing directions, right? Okay. All right. So here's a short little exercise that we can think about together. So for instance, now we have these 2 points, right? Previously, when we looked at direction here, this is the direction of the point itself in world space, right? Like this one is, it's just a line drawn from 0 in the world and then out to 1 distance away from the center in the direction of this point that we move around, right? But yeah, so let's say we wanted to draw the direction between these 2 points. Let's say you want to do direction from A to B. So let's do that. Let's just figure out how to do that, right? So we're going to ignore the center points. Let's just hide those. Let's forget all about those. Let's forget about this too. Forget about everything. You have learned nothing so far. Okay, so now we are drawing a line between A and B, right? So now I should just keep this line. So now the goal is that we want the direction from A, the green point, to B, the red point. So we want that arrow, right? So how do we get a direction between 2 points? Well, the first thing